Okay, so let's try a couple other problems here that involve tangent lines. The first one goes like this. We want to determine the point, or points, if any, at which the function f of x equals x cubed minus 4x has a horizontal tangent line. But when we say has a horizontal tangent line, what we're really asking here is at what point x, what x values give the points where the derivative is equal to 0. Why 0? Well, we say it's a horizontal tangent line. If you have a nice curve, whatever it looks like here, and we don't even particularly have to know what this particular curve looks like, uh, any point where we have a horizontal tangent line means that we have a slope equal to 0. That is a line that touches the graph at a point at which we have probably a maximum or minimum on a nice smooth curve like this. And so we're going to say that we're looking for these points. Well, how do we find them? Well, obviously, one of the things we have to do is we have to find our derivative. And the nice thing is we have this derivative rule that tells us that if I have a function like x cubed minus 4x, the derivative is the sum of these two, the derivative of x cubed, which is 3x squared, and the derivative of 4x, which is just 4 times 1. So that's 4. So our real task right here is to find out, where does 3x squared minus 4 equal 0? What are the x values at which that occurs? Well, if you remember solving equations like this, it would go a little like this. We would take 3x squared, set it equal to 4, divide both sides by 3, so we're going to get x squared is equal to 4/3 in this case. And when we take our square root of both sides, don't forget that means we have to take the positive and negative version of the square root of this fraction, whatever it turns out to be. Well, we're going to go ahead and simplify this using a little bit of arithmetic. So we're going to take the positive and negative of the square root of 4, which is 2, over the square root of 3. And let's rationalize that denominator just to make everything look nice and neat. And so our x values at which this occurs is going to be at positive and negative of 2 times root 3 divided by 3. That's where we get those tangent lines. Well, that's actually kind of a useful result, right? Because we're going to find later on that we want to find such points. All right, here's another more, well, interesting question, shall we say. This time we're given a function and we've got some unknown constant k, but we don't know what line we want to make this function tangent to. Well, what does that mean? Well, what this is going to have to tell us is that, first of all, we already know what the tangent line is. And any function that looks like something k minus x squared is the kind of function in which, if we were to draw it on our x and y axis system, is an x squared graph that passes through the y axis at the point 0k. Why 0k? Well, right, if we say k, if x equals 0, y will equal k, right? And then, of course, any value of x that we put in will be subtracted from k. It's a parabola. With its vertex at 0, k, whatever k is. So how do we find that value? Well, in this case, we do have a couple of tools at our disposal. The first one is that we have to find where the derivative is equal to -6, right? Because those are the only kind of points that will have that value, right? So let's see, what should we do? Well, let's take our derivative. Because our derivative is our slope-producing function, we can say that f prime of x is equal to -2 times x to the 2 minus 1. That's first. So f of x is equal to -2x. And this is our slope, f prime. And of course, the slope that we want here for this line is -6. So what we're really looking for is, where does f prime equal to -6? That is set negative 2x equal to negative 6, and let's solve for x. Well, that's easy, right? Divide by negative 2, and we get x equals 3. All right. So that's pretty good, right? But we still don't know much about k other than at x equals 3, we're going to get that value. So f of 3 will equal to k minus 9. We still don't know what k is, but we know something about what f of 3 is. Well, if this line is actually tangent to the graph at x equals 3, that means that if we go to x equals 3 somewhere here on our graph, let me change color. If we go to x equals 3 somewhere here along our graph, this will be the point where the line has a slope of negative 6. And not only that, that point will be on the line y equals negative 6x plus 1. So what we should really do then is find what the value of y equal y right here along this line at x equals, well, 3. So what is y at x equals 3? Well, y will equal negative 6 times 3 plus 1. That is, y will equal negative 18 plus 1. And we know that number to be negative 17. So these values have to be the same, right? Because whatever value we get for k right here along this line has to give us negative 17 for y, right? So f of 3 also has to equal negative 17. And so now we've got a perfectly good equation to solve. Negative 17 is equal to k minus 9 when k is equal to, let's see, plus 9, when k is equal to negative 17 plus 9, which happens to be 8, negative 8, right? And so our function f of x has to be the function negative 8 minus x squared. Not too bad for a day's work.